Hello everyone, and welcome to Team Victor's EECS 3311 group project, Easy Estates. An overview of the project is that we followed all the solid design principles. The software architecture used was Model View Controller. 6 design patterns were used, including facade, strategy, singleton, observer, adapter, and factory.
For our major design decisions, dependency inversion principle and single responsibility principle were used hand in hand since every component of the application depends not on concrete classes rather on abstract classes or interfaces. And at the bottom level, the concrete classes follow single responsibility principle. The idea is propagated to the callers, and therefore the whole application has every component following both these principles. The Liskov substitution principle was also followed since parts of the application was using polymorphism complying to the principle. For instance, in the machine learning module, the predict method in the parent module is implemented by either of the subclasses, and in the similar sense, the open close principle was used for the different concrete machine learning implementing subclasses, allowing the parent class to be open to extensions while closed to modifications. Interface segregation principle was also used since the logic class was calling separate interfaces for their unique functionalities, therefore complying to the principle. The first design pattern used is the facade design pattern since the whole logic class acts as a big facade. The client calls are made through the GUI, and the logic knows its way around the whole application. It can go to the database, the machine learning module, or the stats comparison, and this acts in accordance to the design pattern, facade design pattern. In the logic class, yet again, there lies a method called forecast, which has a parameter of string called model. So the model over here specifies what kind of machine learning model or strategy should be used. So the logic class, which acts as a navigator, calls onto the machine learning modules subclasses to be implemented here, and the strategy the favored strategy is therefore implemented. The third design pattern uses the singleton design pattern. The main UI class uses this pattern to create one instance of the UI overall. We have a private constructor which is called via the method, a static method, and the method checks for the number of instances that have already been created, therefore acting as a gatekeeper to the creation of the main UI.
The observer design pattern. The main UI class consists of multiple components. The use of the observer design pattern can be seen when we are updating all the views using the main load data component. This acts as a notification between the publisher, the main UI, and all its subscribers. The user will give the main UI the latest information, of which we'll call update view, which will update all available views. The adapter design pattern. Within the machine learning portion of our application, we implemented this pattern. When the logic class is called to predict the NHBI months into the future, it interacts with the machine learning adapter. This adapter converts the given data into a usable data type for the machine learning module classes. The modules then use the data to make a prediction and return the results to the adapter to then convert into an expected data type for the logic class. This maintains SRP, having the adapter be singly responsible in handling the various expected data structures. The factory design pattern. In the machine learning adapter class, we implemented an altered factory design pattern. When the adapter is constructed within the logic class, a machine learning module is passed through as an argument, of which each module implements a different strategy. This creates a new behavior for the adapter depending on what module is wrapped by the adapter. This maintains OCP. allowing the adapter to be open to extension of new modules and closed to modification. The software architecture model used an MVC architecture, Model View Controller, for our application. We have the display component as our view, displaying UI components interacting with the user and displaying charts in an expected format. The logic component is the controller of our entire application, receiving calls from the view and making the necessary calls to the various components that make up the model. Within our model, we have the stats module, the machine learning module, and the data fetcher that interacts with the database. Whenever these modules are called by our controller, the logic component, they perform their tasks and send back the necessary information, where it is then sent back to the display in an expected format.
This is a demo of our project, Easy Estates. I'm Li, a part of Group Vector. For the first use case, we can add some cities, like Alberta, and some other cities or regions. Just add a branch of data of cities. Okay, after we added cities, and we need to choose the time period. So time period, we pick 2000. Okay, and we also can pick the end time of this period. And after we finish the model, we can click load data. Okay, the information of the raw data will appear on the raw data table. Okay, this for first use case. And for second use case, we have the button, these two buttons. One is raw data, one is descriptive data. So in descriptive data, we have mean and HPI, and max, mean, standard deviation, and variance. And yeah, we have the descriptive data for the model. For use case 3, we can add some virtualizations. 4 virtualizations that we can pick. First, we add a line chart. Okay, and time series chart and a bar chart. If we want to add another one, okay, we can have 3 virtualizations and at the same time. If we want to add more, it's not allowed, but we can drop one and add another. Okay, that's for use case 3.
Hello, my name is Hasti, and I'm also part of Team Victor. So for use case 4, we have the comparison. We have comparison by t-test, which is this button. When we click it, we will see all our loaded cities, and we can choose one. And we can also choose another time series. For example, we can choose 2002 until 2019. We will see the comparison result here, which for the p-value of this number, and our conclusion would be we cannot reject the null hypothesis. This is for use case 4. For use case 5, we have the forecasting. We have 2 types of regression modules for forecasting, which is here, one linear and one SMO. For example, for linear, we can do the forecasting. We can choose a city, for a certain number of months. And we also have two choices. One is chart and one is table. If we choose chart, we will have a bar chart for the forecasting in linear regression module. We can also choose the table. It will give us the statistical information for the forecasting. This is for use case 5. And with this, we conclude our demo.